I'm curious where it is.
Well, it wouldn't be anywhere where there's high EMF.
Right.
Fix my hair first.
No, your hair is fine, dude.
You can't film without me fixing my hair.
Show me your sting.
Right
Mr.
there.
Excellent Health got stung the first time ever.
First time ever.
With the bag. The wasp was
There was
in the
a
bag.
goddamn wasp in the bag. Let's see if there...
Where's the adrenaline?
Yeah.
Where's the EpiPen?
Nothing?
Where's the adrenochrome?
Do you have a trash can somewhere?
Yeah.
Is it inside?
You throw it in here.
This is Steve.
yeah,
This
well.
is the Jack Cruise's #1 student.
Don't say it. He'll come
No,
cutting for me.
no, those guys hate each other. And we are cooking the tomahawks. The Nicaraguan ones.
Or if you're an Atlanta Brave fan, it's a tomahawk chop.
Mm-hmm.
Throw it in there. Garbage. Garbage, that's good. All right, I need more.
Wow.
All right, salt those bad boys. I'm going to clean my hands.
Yeah. Talk about the meat.
The meat, this is
How
meat.
did we pick
Oh, wait a
this?
minute here.
This is tomahawks from Nicaragua.
Exactly. And they were half the price in Nicaragua.
Yeah.
Same
that's
stuff.
where we're going. You got them filmed? I'm closing it.
Yeah.
And
Bye bye.
Good. Wow, it's the most meat I've had on here.
Yeah. The Mitos are all about that meat, huh?
Imports to
Show
Salvador.
show us the.
Sting it once more. Right there.
Yeah.
But it's good now. I feel good. It feels.
Yeah.
It's actually interesting. There are treatments where you get bee stings and it's for hair loss, and I think
You are never gonna lose your hair now.
Feeling well, at least I didn't have any hair here in the first place.
Yeah, exactly.
But I get the joke. This drastically increases blood flow. Like this is like red light therapy to the power of 2.
Mm-hmm.
At least generated by your own body's inflammatory response.
Mm-hmm.
So because of that, I think if you get it over here,
Yeah.
there's a reason why they recommend massaging. So,
Yeah,
so you know,
exactly.
you get stings,
Yeah.
especially from some kind of Central American wasp like that.
Yeah, exactly. Let's see if you turn into a superhero now.
Now we'll see.
Yeah. What do you think, Steven? What do you think about this Mr. Excellent Health guy?
I don't know, he's looking a little pale.
I didn't
Yeah.
think you had rings here.
Do a muscle up.
A muscle up?
Turn
Yeah.
blue.
I can't do a muscle up on.
It's-
I can do it on bars. I can.
Really?
I can do other things here.
It's getting a little pale. It's getting a little
These are
grayish.
stable, right?
Grayish.
Grayish, yeah.
And he's only 23 or something.
No, I mean skin is grayish.
Yeah.
He's starting to get
I won't die, right?
hypoxic. I don't know. It's not looking good.
Hypoxic?
Not looking
Toxic,
good.
yeah.
I actually had
Do you feel like
a-
your trachea is tightening down?
I actually had a
You
certain.
look a little dizzy. Do you see two of us?
Okay, let's see the pull up.
Pull up?
Yeah.
No, why pull up? There's
Muscle
better,
up.
there's better stuff.
That's skin the gat. Back lever, skin the gat.
to demonstrate your strength.
Yeah.
Exactly.
He's best at everything, right?
Yeah.
Yeah. That's a tucked front lever.
Yeah, exactly.
I used to do all this shit. In pretty high level, actually. Nice. There we
I
go.
used to do all this shit at a pretty low level.
Exactly.
All right.
I guess
Not
that's
bad.
Alright.
the tradition of
Not
what they used
bad.
to do.
Yeah.
Yeah.
I can
Good
see,
job.
I can see those biceps and those triceps just
Yeah.
growing like he looks like
Yeah.
David.
Longevity going down. Longevity going down, am I right? Exactly. But you already got the longevity going because...
L-cysteine.
Come on, man. Not on YouTube. Not on YouTube.
Come on, dude.
L-cysteine
Relax.
Just kidding with you.
injections is what I need.
Yeah.
How's that for an octogenarian?
Hey, look at this man. Look at this man. Look at the muscle mass. Look at the health.
Yeah, look at that.
Have you
This
ever
guy
used
is
TRT?
83 or something?
It's not a tumor.
He's like 98.
98.
Not quite.
Have
And
you
look
ever,
at the brain. The brain is working so
You can look
good.
right through the brain.
Have you
Look
ever?
at the brain.
It's a definite translucent, right? It goes right through.
Exactly.
And you don't use TRT, do you?
I use TRT.
You use TRT.
Peptides? What's your peptide routine?
Peptide?
Yeah.
All of them. The longer the peptide, the
He
better.
uses TRT. He's never in the sun clearly,
TRT.
and he takes all the peptides.
It's something to do with testosterone?
Testosterone replacement therapy, you know.
Oh,
when they-
TRT. Okay.
TRT.
That's not TRT.
Yeah.
TNT.
No, it's not
TNT.
TNT.
What's your supplement routine? Exactly.
You got it, I take it.
Exactly. Jack Cruz approves.
He is
Am
approved.
I right?
But basically,
Yes.
this guy has probably really good testosterone levels at an age where most people sort of that
Yeah.
are health conscious would be taking TRT.
Yeah.
And what do you
TRT.
do? What do you do, sir? What is
Kennedy
your-
takes TRT.
Kennedy takes.
Don't knock it, yeah.
Yeah. And what
Yeah.
happened with the
Yeah,
glyphosate?
Hey, Junior, right?
What about the glyphosate?
Great, it goes hand in hand, right?
Ah.
It's like the cake with the icing on top, right? Got the glyphosate on top of the TNT, TRT.
TRT.
TRT, yeah.
I see what you're talking about. A
Glyphosate.
smart man. This guy's a smart guy.
It inhibits my melanin.
Exactly.
Go back to Chernobyl, right? So Chernobyl's got the fungus. They've got the frogs that are changing. They're getting more melanin. And I don't think that's a current mutation. I think that's an atavistic event that they went back in time,
Yeah, exactly.
right? So they had the ability to do it all the time.
Yeah.
So now not only are they protecting themselves from gamma rays, but they're actually utilizing them to make more energy. And they're growing 3 times faster than the ordinary fungus.
Yeah, exactly.
So now come back to humans. How do we do that? We have it in our system to do it, right? We have beta decay going on all the time, right? You have elements that have their half-life. They're breaking down into other elements. They're transmutating, right?
Yeah.
So when they transmutate, you have a daughter cell, a daughter element that has extra energy. So it has to give off that energy. It gives it off in the form of a gamma ray. So what happens to that gamma ray internally? It gets absorbed by melanin, right?
Yeah.
So now that melanin either turns it into chemical energy or some kind of a light form, and we're actually using that.
Yeah.
So now how do we increase that ability? We're already using it with beta decay, right? The gamma rays. So how do we increase it? Even to go, so I got thinking to the point where we have IR light that we get a solar callus, right? So that solar callus protects us from UVA, and then protects us from UVB. We work our way down the scale, right? So we get a lot of melanin from UVB. So now maybe we can drop down to UVC, right? So now we're getting a callus working our way down to a higher energy level. So we got the UVC. So what's next? X-rays.
X-rays.
So maybe we start pumping ourselves full of a few X-rays. Not a lot, but just enough that we have enough melanin that's going to absorb that extra energy. And you know what happened when we were able to convert oxygen into energy, right? We got smarter.
Yeah.
We adapted.
Yeah.
There you go.
So maybe Marvel with the whole Hulk story was right.
Hulk. No. Hulk. You're going down the wrong. You're going down the wrong way here. So anyway, radiosynthesis.
Yeah.
Right. How can we utilize it? I think there's a way. I think we can figure it out. Jones is a smart guy. I think he can figure it out.
Well, I was just gonna say that. Thank you for your kind words. That we naturally have cosmic radiation, right?
We have gamma rays, not cosmic radiation.
Cosmic radiation, isn't it called cosmic radiation? Isn't that what comes from?
Yeah, but it doesn't come. Well, once in a while when you have the tunneling from.
Well, what I do know is that Cruz has said that when you have more clouds, more like a cloudy day, you have more cosmic radiation.
It's gamma rays though.
It's gamma rays?
Yeah.
I don't think it's cosmic rays. Yeah.
I thought it was two
Maybe
different parts of the spectrum.
Yeah, it is.
But-
But I think cosmic rays are stronger. They're even more energetic.
Yeah, exactly.
Yeah,
And so
so-
that's what we get
Yeah,
through.
I wouldn't go that far yet. Let's stick with gamma rays, right?
Yeah.
What I
Let's stick
do
with
think is
Chernobyl. I
that-
don't want to
Yeah.
go. Yeah.
Fukushima.
What I do think is that since this is a natural part of the human environment here, sort of, where we are. Of course, the higher you go, the more there is, but sort of here, and the altitudes where humans live, there may be radiosynthesis going on, because if you have melanin,
Oh,
it
there
can
is.
absorb.
Yeah, there is,
Obviously, is
definitely.
because we got beta decay. So we're making gamma rays.
But also so that's internally, right?
Yeah, internally, right?
But what you're talking about is externally. So
Well,
I'm talking
an external source.
I'm talking about the cosmic radiation actually being external, exogenous radiosynthesis.
Right, something we could do, but I don't
If you're
think it's
healthy.
getting. I don't think it's getting through. Very little's getting through. I'm thinking of
Yeah,
an artificial
it's that
source.
Little. It's that
Very, very
little
little.
signal that may have a huge effect.
So a couple things come to mind. First of all, you could maybe run an experiment. I don't know how ethical it would be, but you take somebody like in Nairobi, who has like, Fitzpatrick 6,
exactly.
purple.
Yeah.
You start exposing them to, because they're already getting UVC, right? They're already getting UVC. They're at the equator. They're at what 8,000 feet. They're getting UVC. They're purple. So
Are they?
they're dark, like a
Almost.
dark
The
purple.
lowest,
It's
the
al-
lowest is 250, I believe.
Yeah,
from the
well,
atmosphere.
yeah, but you're at the equator, so it could go down a little farther. You're at 8,000 feet at the equator.
I believe the lowest that's ever been observed is 250.
Okay,
but
we'll
if
say
there
two-
is
okay.
UVC, that would be really interesting.
So it is UVC. 250 is
250,
UVC.
that-
280 to
is
3.
220. Anyway, it's semantics. Don't worry.
Okay. Well, anyway, I thought 280 to
UVC.
315 was UVB. Below 280 was UVC.
No, I think UVB continues down.
Okay. And in any event, so that'd be a good experiment. The other one, and I'm blanking. It'll come back to me. So say you got the UVC going, right, and I've actually got a UVC light that was given to me, so I can try it. UVB, UVC. I think it's in the very high UVC range, and it was created by mistake, and they told me not to use it, so I started using it on my light. Anyway, so
Did you feel any benefit? Did it still
What is
anything?
it? Polarized
no, I did it in
light?
Mexico, and it's just regular artificial light, so
Yeah.
it's polarized. So
Yeah.
I did it on my legs, and from my knees down was really melaninated, and I had no problem from the knees up. It was not that melanated, and I had a little
Yeah.
erythemia, a little red
After doing it.
after doing the C, and I only did it for a couple minutes, right? But I'm going to start down here because we have more sunlight and
You're
see
a
what.
crazy man.
Oh no, I
He's
think it's
experimenting.
because we're making UVC, right? 220 for our laptop.
Yeah,
Yeah,
inside.
but endogenous and exogenous is very different.
Well, we'll see.
The intensities are very
Anyway,
different.
so
We'll see.
you need
so
you need to get more dark still.
So anyway,
if that's the thing.
so my question is, if we're getting benefit from say UVC, how is that measurable? What are we going to look at in labs, or how are we going to measure?
I have an idea.
Yeah, let's hear it.
Yeah, well, so usually when you look at if something like a hormetic stressor is actually having a benefit, for example, with intermittent hypoxia, what they do is they sort of look at the pathways that are activated, and then usually you have again a certain stress, but then they remeasure certain markers, and those markers are sort of heavily linked with mitochondrial protection, health, etc. And they look at if they've been elevated or not, and they also look for signs of damage. So then you're controlling on all sides, right? And then you're controlling for other variables, where the people's environments, and you're also controlling for light, all that, because that's going to interfere.
Right.
So you do all of that, and then you do the UVC, and you look for signs of damage, look for signs of mitochondrial dysfunction. You also look at these things that are usually activated by hormesis, right? And then you look at mitochondrial function after a few sessions of it. And if you see that the antioxidant activity is higher and mitochondrial function based on objective markers is better, then you can conclude that yes, it was a positive experiment. And then what I think we would need is several groups. You of course need a control group. It's just purple light. Then you would need a group that's Nairobi people. Then a group of people with maybe good tans or just normal people. Who knows? It's gonna be difficult to conduct though because from an ethics board perspective, UVC is supposed to be cancer-causing and dangerous.
Right.
So that's the way I would do it.
I would look at it in terms of not a hormesis effect, but more of an actual radiosynthesis effect. Because I know people they got the bomb dropped on them in Japan, right? You had the people right at bomb site vaporized, then you had people a next radius out, and they got cancer. They got these long-term effects. Then you had people the next ring out, they got a small amount of this radioactivity, and they actually did better in longevity than people who had no exposure.
That's what I'm saying. I think
And
that's
that's the hormesis effect.
Yeah.
I'm talking about radiosynthesis, where it's not causing any ROS. It's not causing any.
it's just being utilized as
It's
energy.
being utilized as energy, right? The melanin takes it up, and then it shoots it back out. in chemical energy or different light frequencies.
Cruz has recently been saying that different melanins have been developed at different latitudes, right?
Right.
What I think we need for radiosynthesis, exogenous radiosynthesis, would be new forms of melanin that develop because of the environmental stimulus. That's what I think we would need.
And that's what we probably will, because they started out with allomelanin, right? Before we even, almost before there was life. Mm-hmm. And now there's eumelanin, there's pheomelanin, there's neuromelanin, and they're even making artificial melanin now, seleniomelanin from selenium, right? To put on stuff. And they're actually thinking about making artificial melanin to put on people when they go in for x-rays. So some people need multiple x-rays for whatever the reason, right? Medical. And in theory, it's going to protect them from the x-rays so they don't get a lot of damage. They don't get nuclear DNA problems.
What I think we should do is, what are they called? Freons, right? Freons? The thing that destroys ozone. I think we should just release a bunch of that, remove the atmosphere, and then we can see if you're...
Now you sound like MK Ultra.
So the other thing is too, you've got the nuclear power plants, right? And so what do they use to surround they use water, right? But they use heavy water.
Yes.
They use deuterium water. Why is that? Because electrons don't stop it, right? But what stops it? Protons and neutrons stop the gamma rays. They absorb them, right? Because there's more energy in the nucleus, so that's able to control them. So the more particles in the nucleus, the more they control them. They stop them, right? So I'm wondering if you're running an experiment now, maybe it might be beneficial to drink maybe heavy water instead of DDW. You go the other way. You drink, instead of 150 parts per million, you might 300 parts per million, right? So now we've got more protection where we need it, and if our mitochondria are working fine, we're going to drop it down to 120 anyway, right? Our CCO is going to drop it down and make DDW where we need it, but where we need more of it in our plasma, right, to protect our red blood cells, our cells, right, from the damaging effect, we've got it. We've got deuterium, we got the neutrons, right?
You would need a system that's even better than ours for separating deuterium from protium.
Maybe not.
That's the thing. Because why is heavy water dangerous? Because that system doesn't exist. It's all dependent on the deuterium intake.
Right.
That's why heavy water kills you. Because you need, the way Laszlo Boris explained it to me is, although you're consuming, how do we say? Is the tomahawk?
Let me check real quick.
Yeah, let's go check the
it's
steaks.
in the maybe a minute or two, but I don't want to overdo it.
They sound like they're sizzling.
Oh yeah. Mamma mia.
Good?
What do you think?
Yeah, that's great.
Yeah, that's great.
That's good?
Yeah. Okay. So we know that seals have way more deuterium in their collagen, right? Up to, I think, 400 to 600 ppm, something like that. So here's the question. Instead of relying on the mitochondria to be able to distinguish, or having an extra system to separate out the deuterium in the plasma as opposed to the deuterium in the matrix, keeping it deuterium free, hopefully, or at least very, very little, why not put it in the collagen where it normally goes, but put more in the collagen, and then, of course, have this collagen structure be hydrated in such a way where you've got a bunch of water and you've got a bunch of deuterium in there, where that creates the shield. You see what I mean?
Right.
Having that as the exterior. But maybe you need the water to be it, because water will sit. You'll have more protons and neutrons being more dense.
Right. There's different ways of doing the shield, but I'm trying to take it to that next effect, right? Where not only do you protect yourself from these high energy waves, but now you can utilize them. absorb them, make them work, right? And I don't think collagen is going to do it. I think melanin's the key, but you need to have enough melanin or a small amount of energized radio waves, right? To radiation waves to make it work. If you get too many, and the other thing is too, you know, when I was listening to Feynman the other day, and he was talking about light and how it goes through, say, windows, or it doesn't go through windows, and why is that? And I got thinking about it, and he says most of the first year physics students get it all wrong, and I got it wrong too. And I thought it was because of the length of the wavelengths, right? So if there's longer wavelengths, it's going to go through, right? Shorter wavelengths, it's going to block it. But that's not how it works. It works, you have the longer wavelengths, like say infrared, right? So it's going to go through it, and you have electrons in the molecules of the window, right?
Yeah.
And each one of these electrons have a certain energy that they can absorb. So think of it as a ball going up a stair. If you kick it too hard, it's going to go way up. If you don't give it enough energy, it's not going to go up, right? So you've got, and there's a range that can make this ball go up or down, this electron go up to the next energy level or not. And it might be, you know, say 600 to 700, and you're in the red range. So anything, say 650 is ideal, so that would make it jump every time. So 620, it'll go a little bit, 680 will go a little bit. So now you have infrared light going through, but it's not going through at 100%. It's only going through right in that sweet spot. So now you've got maybe 40 to 60% of the light going through, and 40 to 60% of the light being blocked. Now you come down to blue light, right? So blue light is right in the sweet spot of these electrons. So there's not.
That'd be Owen. I heard someone knock.
It's probably just the iguana. So,
Interesting.
Yeah.
So you have the blue light, right, and all of it goes through.
Yeah.
So none of the electrons have an energy level that's going to absorb that blue light. So it's all going through. And then you have, say, X-rays, right? And all the X-rays are going through, even though they're really short, right? But there's no electrons that are able to absorb them.
Yeah.
Right? So some of the protons absorb, but there's not enough protons around. So most of the X-rays go right through, right? So UV light, it's at the energy level. Maybe that is him. Yeah. Energy level where it all gets absorbed. So you lose all your UV. So no UV goes through these windows because the electrons are at the energy level where it's going to absorb all of the UV light that goes through. It's not going to go through at all because it's absorbing them. So, and I always thought it was just the length of the wave, but it's not. It's the energy level that they're creating and the electrons and what they're able to absorb. So that was just fascinating for me.
Wow.
So it's something that I didn't know, you know, and yeah. Anyway,
tomahawks.
Tomahawks. Yeah. So that was another interesting thing.
Wow.
Is that? Oh, there he is.
That's Owen.
It's Owen.
The Australian warrior.
Orwellian.
Orwellian.
How you doing?
Hello, Owen.
Hello. I was thinking of that Orwell quote.
Huh?
I was thinking of an Orwell quote this morning.
Really? What?
The one that says the party taught people to prefer the information presented by the party rather than the evidence of their eyes and ears.
Yeah.
It was their final and most essential command.
Wow. You really know your poetry. You got to thinking that when you were talking with Bridget?
I might have some China, maybe.
Bridget and Anne-Marie.
Oh yeah.
Yeah.
Yeah, they have a little bit different view of the world. Let's just say that.
Yeah, you're not wrong.
Yeah. We have tomahawks.
Oh yeah. Beauty.
What do you think about the tomahawks? Yeah. You like tomahawks? She loves tomahawks. Yeah.
So if that is the case, you're saying that we can control beta decay. So if we can control beta decay, then we can control the amount of gamma rays that we're giving off endogenously, which means that we actually could, if we can control the rate of beta decay, we can increase our energy through gamma rays if we have enough melanin, hydrated melanin. So you're saying that's possible if they can transmutate into other elements because of biological system, right? Something that we're actually doing, then we can actually create more gamma rays and give ourselves more energy if we know how to do this or how this is working. Can you follow that logic?
Yes.
Okay. All right. What do you have to say about that?
If the transmutation is happening because of the gamma rays, then yes,
gamma rays are a product of transmutation.
So how is that? What's initiating? What's the physical mechanism that's initiating the transmutation? That's the thing.
Well,
Whatever
it's beta
that
decay.
is,
Beta decay.
Beta decay.
Yeah.
So then we must have some. If beta decay is the way it's happening, and I'm guessing that there are several ways for it to happen. I don't know if this is the only one based on physics. I haven't done research into that. Then we have a way of controlling that, because we
There
do
you go.
know that we have a way of controlling transmutation based on the very,
demand.
very, based on demand, because that is what seems to be controlling it. How can I give you an example? Yes, there's the chicken and the egg situation where they're creating a lot more calcium as opposed to a human being. But there's also all these environments that human beings are in, and although the environment influences which nutrients you need, there are still enough similarities between human beings in different environments that makes it so that you need different elements. And it seems as though if you're an Inuit or someone in the Amazon rainforest, you're going to be eating very different things, getting very different minerals, but you'll still be functioning. And I think the way nature has dealt with this is through transmutation. And this is why Cruz says that nutrition doesn't matter as much. This is why David Herrera this is what he explained in the interview I did with him, that no other nutrients outside of DHA and avoiding linoleic acid does not matter as much, because you can create all of them. And if we can create all of them, it is implied that we have a way of detecting what's going on in the body, how much we have of everything that we need, and we have a way of deliberately creating it, one step of that being transmutation.
We can create a lot of things that aren't through transmutation, right? Just changing the molecules around. So here's something else to think about. So we'll go from the other direction now. Say you got beta decay going on, right? And you're giving off gamma rays. You're transmutating into whatever you need, right? To calcium, we'll say. You're giving off gamma rays, right? The daughter cells, that calcium daughter cell now, is going to give off gamma rays. So we have melanin, hydrated melanin, that's protecting us, and also hopefully utilizing that gamma ray to give us more energy, to give us an advantage. So beta decay is happening, right? It's happening. So what happens if we don't have any hydrated melanin, or we don't have very, very little melanin? Now this gamma rays become a really, really bad thing for us, right? And we can't control them, we can't stop them. I mean, half-lives of elements happen all the time. So probably worse than ROS and RNS is these oxidation, this damage, and the gamma rays it's more than just ionizing. It's creating isotopes. It's destroying protons. It's destroying neutrons. It's destroying whole nucleuses. It's that strong, right? It's stronger than UV light. It's stronger than it. So we're actually destroying or changing our DNA to mutate. So now we're causing things like cancer, right? So it would make it more important to have melanin. It's like hugely important now, because we know we're getting zapped by gamma rays because we have all these elements that have half-lives in our bodies, and they're changing at random, right? It's transmutating at random, giving off gamma rays, which is destroying our DNA, right? So if we don't have the melanin to absorb it, that's one more problem we have. That's one more vote for melanin, hydrated melanin, right? So it's one more thing to think about or worry about, depending. If you don't have melanin, right? If you're white as shit, you're in big doo-doo, right?
Exactly.
Right. That's something to think about. It's one more thing, right? It can be a double-edged sword, right? This gamma rays, we can take advantage of them. We get the melanin, we're getting more energy, we're protecting ourselves. Or if we can't protect ourselves, we can't control it. We're not the fungus now. We're not the fungus in Chernobyl. We're the fungus that couldn't make more melanin, and they're dead meat. That fungus is dead, right? That's dried up on the walls of the reactor, right? So, it's different. We have to adapt. We have to adapt to a changing environment. So if we can change our environment, maybe it's not a good thing. If we can change our environment to actually produce more beta decay in certain directions, that might be a good thing, maybe not. And there's a certain balance that goes on here, right? So maybe that UVC that I'm going to shine all over my body may not be a good idea. It's maybe I can adapt. Maybe I can get the solar callus to actually take advantage of it, to create a radiosynthesis type environment. Your turn.
My turn?
Why
I didn't
you-
ask a question, but
No,
I guess,
just add to the
I guess
conversation. What are your thoughts?
I have two things. One, to translate to the viewer. Hello, viewer. What Steve is talking about in terms of the gamma rays and the protection is that normally we have hydrated melanin that takes care of the electrical charge. So mitochondria, or our human bodies in general, are creating, I think, 10,000 times more energy per square centimeter than the sun. That's just because of the mitochondria. And so there's this 30 million volt charge.
You mean the sun per square centimeter, or the
the sun per square centimeter.
Right.
You're
So it's
creating
not
more
the-
energy.
Not
Right?
the aggregate.
You're right.
energy
Same
of
to
the
same,
sun.
same
No.
quantity to same quantity.
Right.
Right.
Yeah.
Okay.
In terms of, I guess, measurement. Yeah, exactly, measurement of volume. So, in the inner mitochondrial membrane, you have an electric field of 30 million volt per meter, right? 30 megavolts.
A lightning bolt. Yeah.
So, if you don't have insulation in the right areas, you're gonna fry yourself. Now, what Steve is saying is that not only do you have to worry about that, but if you have this process of transmutation that is dependent on beta decay, that's releasing gamma rays, you don't have adequate protection to protect you from that as well. The other thing I'll add is that the reason why ionizing radiation is dangerous is usually it's not interacting with, say, the organic molecules in the body, the carbon-based stuff, the collagen, all that. It's not interacting with the proteins for the most part. It's interacting with water, and what it does is it produces free radicals from that water. That's at least what Nick Lane says in the book Oxygen. And that's why it's so dangerous, because you get a sudden burst of hydroxyl radicals that completely fry you. And the body, free radical production is usually controlled, and it's a very specific signal, and I would say that in a healthy human being, it's an absolutely necessary signal to take care of the mitochondria. But in this context, when it's just happening randomly because of the ionizing radiation, you're going to have a huge problem. So that's what I'd say.
So ionizing radiation means that certain wavelengths will be absorbed by electrons. When they get so strong, those electrons can't absorb the radiation. So what stops it? That radiation will go. That gamma ray will go right through you unless it hits a proton, something in the nucleus, or a neutron. It hits something in the neutron and it destroys that nucleus. Right? It might be DNA. It destroys it. So it's so strong that it actually destroys your nucleuses in your cells. It destroys them. So if you get DNA, it destroys that DNA, or it changes it. It mutates it. So now you have DNA that's sending signals out to be transcribed by your ribosomes, and now these proteins are mutated. They're not right. They're not the dimension that they're supposed to be. They don't have the shape they're supposed to be. So now they do stuff they're not supposed to do. Maybe grow too fast, not give the light off, not give the proper signal they need, on and on and on. So ionizing radiation means it's knocking down that nucleus.
May I counter?
Sure.
The way I understand ionizing and non-ionizing radiation is that one is ionizing because it creates ions. So unstable molecules that require for the most part, you're knocking away an electron. So what happens is that it becomes a positively charged ion that wants to steal an electron. Non-ionizing is doing other things. It still can be very problematic because Wi-Fi is non-ionizing, and we know the biologic effects that has, calcium efflux, for example. But with ionizing, you're actually taking the electron and not just giving it more energy, like what you have with Wi-Fi. And then it returns to its normal state, and then you have signaling going on awry. What happens is that you knock off the electron, and this usually happens with water in the body because that's where it's going to be absorbed. So when that happens, out of the water, you create a free radical. Usually, as far as I understand, a hydroxyl radical. You could also create hydrogen peroxide. You can also create superoxide. All those three, depending on sort of the interactions therein within the water. how much is being knocked off, etc. It's all down to probability at that point. It becomes another discussion. When you have that, the free radicals themselves are the things that are hitting the nucleus. Because you have so many molecules of water that the ionizing radiation isn't hitting your DNA. That's very, very difficult to hit the DNA. What's happening is that it's hitting the water. Free radicals are being created in the water, and then that's damaging the nucleus. So these chain reactions. Mm-hmm. That's as far as I understand it. That is what I remember reading in Nick Lane's book.
Mm-hmm.
Yes.
Mm-hmm. Okay.
Okay. There's toucans over there.
They're brutal.
Yeah.
They attack the little birds.
Toucans.
And kill them.
Kill them. Yes.
There are toucans over
Yeah, toucans. You can see them.
Big build.
They're pretty cool. Do you see them?
I can see their beaks. I see two birds moving there, but I
Yeah,
can't see two
there.
beaks.
I see.
Just in the tree in the distance.
Yeah.
Furthest tree.
You can see the peaks.
Whereabouts in the tree?
I see
Right
two
in the
birds
middle.
moving right in the middle, but I can't see the long beaks of toucans. I just see two normal birds. Maybe
So-
because of my position.
Or your vision.
Maybe my vision as well.
That's a
yeah.
problem with eating cooked meat.
Yeah. Cooked
As
meat
a-
does
what's
that.
You should have put it on
Become
Steve.
myopic.
Those are the
Yeah.
better.
Myopic
I know a
fucks
lot
over
about
here.
I know a lot about being myopic. trust
These
me.
myopic fucks. Yeah, I can see them pretty well.
I can see them kind of in the middle of the tree, but I can't see the beaks.
You cannot see the Beckers?
What happens when you
I
can
can
see
just
the
some
tree,
movement,
the
that's
tree
all I can
moving?
see.
Yeah, there's two.
Maybe
They
that's
might
why, I don't
have
know.
sex there, like when you were speaking all that. Like I was looking at them and they looked like they were having some fun.
What, the birds?
Yeah,
The toucans?
yeah, exactly.
You were just
They were like onto them.
You were getting a bit hot.
Well, they've
hot
been-
under
they've
the
been-
collar while they were.
Yeah,
Obviously, they've been sunning their balls all day long.
yeah, exactly. Yeah, am I right?
Yes.
You're
And,
right.
and their feathers are so full of melanin. My God,
My God,
they're like a
teed up
missile.
over there.
They're like a missile.
Radio
Little horn balls
Yeah,
over there.
Yeah.
They don't have the same
They could have
problems.
just got out of prison, out of their cage.
Yeah, as the modern
heat right
people.
Okay, comment on this. Joe told me the other day that cum is
Cum.
deuterium heavy, and
Come.
if you orgasm more, you'll deplete your deuterium.
If you what? If you
If you come more.
Come more.
you deplete your.
Ah!
So what
So
hell
this
kind
guy's
of
full of
thing do you have over there
deuterium.
going on? Yeah.
Did Jack say that?
Yeah, Jack's always all about coming.
Did Jack say
All
that?
about, yeah. Come into
Jack's
town.
always all about coming.
Yeah.
In the sun,
Yeah.
in the sun.
Yeah, all the time.
Under blue light, it's
Yeah.
no.
Yeah.
Wait, so did Jack...
So this guy's full of deuterium.
Yeah.
Because
Oh God. It's coming out of his
this
ears.
guy hasn't come in years, I bet.
Years, right? Yeah. You're heavy.
Yeah, no, I put that. Listen. I
You're
put it
heavy.
on my. I
get
put
him
it
on
on
the
my
sk-
collagen. I have better bones than you.
Get him-
Yeah.
How much you think he weighs? Get him on the scales. I bet he weighs over 200 pounds.
What do you have to say, girl?
25.
Jeez, I don't believe you.
Yeah.
Damn humans.
Oh my, these guys are
200 pounder,
idiots.
right?
Retarded. Myopic fucks over here.
A 200-pound friend.
Imagine
He pooped on you.
Oh, you filmed it.
Yeah. The squirrel
Exactly. I got mine.
pooped on excellent health.
Excellent health was sitting on this chair.
Yeah.
Peacefully, right?
Yeah, he was in
The
excellent
squirrel-
health.
The squirrel.
And squirrel.
The squirrel deliberately goes exactly above where you're
Yeah.
sitting, right?
Sneaky little
And it's-
bastard.
And it starts eating right above you.
Yeah,
And
exactly.
before there were mangoes, you know what it does? It does
Yeah.
the same thing.
That's why we hunt.
And it lets.
That's why
exactly-
humans
exactly.
hunt.
That's why we.
What do you think, Owen? What do you think about this?
Think about what?
This excellent health guy over here.
Ah, charlatan.
Oh,
Exactly.
oh, you're like the raw meat guys online, bullying
We are indeed mistreating animals.
Yeah, yeah.
No,
Get the squirrel. I want some raw meat.
You want some raw meat?
Mm-hmm.
Yeah, you gotta bring me some better weapons, man. Try
Oh,
to get him with his own food. They threw a mango at him.
oh yeah.
It was not intended to hit the guy.
Aha.
It was intended to get him to go.
Ah, noticing.
Because we don't want this stuff to come.
Yeah,
out.
the animal poop is not healthy for us.
Yeah, exactly. Well,
Yeah.
That depends.
Oh yeah. Some more.
I've seen it be a good probiotic. Eh?
Oh, you tried it?
No, actually, I've tried many things, but that I haven't tried.
Oh yeah. But some
Funnily
people, we have found out some people are addicted to the poop.
Not here, but in certain circles.
Yeah.
Definitely.
Yeah.
Definitely.
Yeah.
That I agree with you.
That's how it goes. Any last words, Owen?
He's not a charlatan. He's a very wise man. I often get advice from him. You should sign up for his
Thank you.
sign up for his community.
Really? Are you a member?
Money well spent. No, he just tells me everything for free. So
Oh,
I
yeah.
don't need to be.
That's the way. You have to come here
Owen's
and get the free knowledge.
Owen's most people down here are really nice people, especially Owen. So,
Yeah.
you know, I can't resist.
Yeah.
I can't resist.
Yeah, he's too good of a man. Although today he ate all the brisket.
I did, and it was cooked. It was cooked
Yeah.
brisket, and I went for.
And there was nothing for anybody else,
I
basically.
was specifically looking for all the food. Hey, listen, I'm a 23-year-old man. I'm growing. Look at me.
Yeah,
I need
look
to
at him.
maintain
He
this.
needs the
I
food.
need to maintain this insane
He's
mass.
growing 6 feet tall over here in El
Exactly.
Salvador. Tropical sunlight.
So how many centimeters do I have left? Let's see. 4 plus 24.
Or-
29. I have 29
Yeah.
centimeters.
Just couple more briskets,
Couple
and
more
he will get
briskets and
there.
I'll be there. Like
Yeah.
this brisket is like, I don't know,
Yeah.
6 centimeters or something.
Yeah, but save some for others. Like there's some sick people over
Listen,
here.
I paid for it.
Oh yeah, how much? How much?
$5.
And what do you get for $5?
Well, here you'll get it. You'll get.
Oh yeah, in
stuff-
Salvador.
Hey, listen.
Yeah.
Ground beef, 1 pound is $4.
Exactly.
The one from Nicaragua.
But
Where's this meat from, my friend?
Nicaragua.
From Nicaragua.
Hell
Listen,
yeah, Nicaragua. Hell
I
yeah.
eat a pound. No, I ate less than a pound.
Well, I don't know. I don't know. What do you got to say, Owen?
Oh well. Look, maybe he was doing everyone a favor. Everyone else is kind of fat.
Oh.
They needed a mic.
Yeah.
See, excellent health is
Yeah, look at that. He really is that wise.
Look at him.
He's the prophet.
Yeah, that's right. He's an
Look
Adonis.
at this.
Look at that. Look at that belly. That's excellent health.
This is excellent.
Yeah. Anterior posture.
Huh?
Anterior dominance.
Yeah, exactly.
Yeah.
Anterior belly tilt.
Yeah, exactly. The Jack Cruz
It's a
method.
dome, yeah. Well, I guess if you go by appearances, sure, that's the way to describe
Yeah.
it.
Exactly. Another beautiful day at the El Salvador jungle.
Am I famous now? Will this be on YouTube?
This will be on YouTube.
God damn.
And I'm not gonna ask you.
You're not gonna ask me.
Yeah.
I'm gonna see you.
It's gonna be there.
You're getting sued.
Yeah.
Do people know your name?
Huh?
Do people know your name? On
No, but I'm gonna end
So
it the video right
So
now.
I can't say it.
Oh, you can, but it's Mr. Best Science.
Oh, yeah, exactly, Mr. Best. Yeah, based
Best Science, exactly,
Best science.
exactly.
Best science.
Based.
Based science.
Yeah.
Okay.
You know what based means?
Yeah, yeah.
Based in reality.
Yeah,
Exactly.
So our dear friend has been documenting many places, and as you know, knowing a lot about locations on the planet and which place is the healthiest to go to is very important, and so there's great utility in his channel.
I know.
So go check out all those videos because
Yeah, and
you never know. Once you really, if you see a place and you really want to go there, you really find that that's your dream spot just because you found it on YouTube. And I guess with Jack Cruz's work in El Salvador, that's going to be the
Yeah.
same way for many people who wanted to live down here, for example. I think every day you spend until you get there is going to be way more meaningful because you're on a mission to get to that place. Trust me, once you get to that place, it's like you were in World 1, say in Mario, and now officially, if you're young, you're in World 2.
Wow. And on that message, see you later, alligators.